Hey there. This is going to count as part 4 because something happened with the part 3 that like messed up the last part of the last video. So test, test, test. Looks like it's recording. So let's continue. So use the additional formula to find the exact value of sine 75. So I'm going to use this formula to find the exact value of sine 75. So I got to use one of these formulas. It's said the addition formula, so I'm going to use this one. And I said in the last video, I will not include anything that's tan. I will limit it to the sine to cosine. So don't worry about any tan versions of the sum or difference formulas. Keep it to sine and cosine. So in this case, sine a plus b equals this formula. So I need to change 75 into something I could add where I know the units for. So I'm going to do 30 plus 45. Those are things that I know I can figure out the answers for. So in this case, it's going to be sine 30 plus 45, which means I'm going to follow this formula. So sine my A, 30, times my cosine of my B, 45, plus my cosine of my A, 30, times the sine of my B, which is 45. Well, sine of 30, if you know your unit circle, hopefully like I do, which is probably sometimes mistaken, but you could always catch your mistakes. 30 is the long one, so it's kind of short. So it is going to be the half times cosine 45 degrees. Good thing about 45 degrees, sine and cosine is the same. So root 2 over 2 plus cosine of 30, which is again, the long one. So that's going to be root 3 over 2 times sine 45, which is root 2 over 2. Combine this part, that's going to be root 2 over 4 plus root 6 over 4 to make it one big fraction, root 2 plus root 6 all over 4. If you remember, these are kind of how the answers always end up looking like because we don't really mix it up that much. That's the real answer. That's the real reason why. Use the difference formula to find the exact value of cosine 75 degrees. So cosine 75 degrees is going to be, we're using the difference formula, so I'm using this formula here. So I'm going to do cos A, cos B. Oh, I need something to subtract to 75. So I could do, like I would like to do 90 minus 15, but the problem is I don't know what 15 is, so that's not a good mix. So why don't we do 120 minus 45. So it's going to be cosine 120 minus 45 equals, now I use the formula, cosine 120 times cosine 45 plus sine 120 sine 45. So cosine 120, that is the same as like a 60 degree. So that is going to be, because it's on the left, negative root, or negative 1/2. Cosine 45 is root 2 over 2. Again, 45 is really nice because it's the same both sides. Plus sine 120, that is 60 degrees. So that's going to be root 3 over 2, but positive, times sine 45. So that's going to be times root 2 over 2. Clean it up and make it one big fraction. Negative root 2 plus root 6 over 4. Like I said, they kind of always look similar. There's nothing much to mix it up with. All right, if cosine x is in 4, 5 and is in the first quadrant, find sine of x over 2. So we're going to need a half angle for this. So I'm going to pause and pull out the half angle formulas. All right, welcome back. Test, test, test. Is it working, looks like? All right. So in this case, it's cosine x equals 4 over 5 in the first quadrant. So we know it's in the first quadrant. It's over here. Find sine of x over 2. So I know cosine x is 4 over 5. So let's just do that real quick. I know x is here because it looks like this. Cosine's 4. Hypotenuse is 5. I can figure out this is 3 because it's a 3, 4, 5 triangle. Find sine of half x. So I'm going to use the half rule for sine, which is this one over here. So it's going to be square root of 1 minus the cosine of my x value over 2. But I actually know what my cosine of my x value is. It's 4 over 5. So in this case, I'm going to replace it, which actually, since I said it was 4 over 5, this was kind of redundant. I didn't need to do that. If I gave you something else, like secant of whatever, you needed to do it so you could find cosine. But I gave you cosine, so it kind of made it easy. So 1 minus 4/5 over 2. Well, 1 minus 4/5 is 1/5. So 1/5 divided by 2, 1/5 divided by 2 is 1/10. So your answer should be the square root of 1/10. Next one. If cosine's 4 over 5 in the fourth quadrant, find tan of 2x. I straight up told you I will not use a double formula for tan. Don't worry about that. Let's go to the next test, which should be just 10. Test 10, which is all that circle stuff. All right. PQ is a tangent. Because it's a tangent, I know this is a right angle, even though I drew it. And because it's a right angle, I can use Pythagorean theorem. I would do x squared plus 24 squared equals 26 squared. 24 squared minus 26 squared. So 26 times 26 minus 24 times 24. A little bit of algebra, you'll get x squared equals 100, so x equals 10. You don't use the negative version because you're talking about an actual distance. In this case, this is a little different over here. I need to do a squared plus b squared equals c squared, where this is a, this is b, and this is c. But in this case, it's going to be x squared plus 30 squared equals, this whole line is the hypotenuse. So it's x squared, or I'm sorry, not x squared. It's x plus 18, the whole thing squared. So it's going to be x squared plus 30 squared equals x squared plus 36, x plus 18 squared, which is 324. This is 900. I could subtract the x squareds on both sides, which gets rid of this. It gets rid of this. Then I could minus 324 on both sides, so 900 minus 324 equals 576. 576 equals 36x. Divided by 36, x equals 16. So the answer is 16. Next one, give the measure based off what's given. Now, let's figure out some things. First off, Kn looks like a diameter. So I know from here to here should be 180. Since I know here to here is 180, I know this little piece in between should be whatever's left over for 180. So that's 87 plus 68. Take that and subtract it from 180. I should get 25. So this little guy is 25. If this is 68, I could concur that this is 68. And then this also is a linear pair or a semicircle, however you want to think of it. So 68 minus 180, that's going to be 112. From there, it's pretty easy now. I just plug in my numbers. LM, 25. JK, 68. NJ, from N to J, that's 112. LMJ, so I got to be careful when I read this because I go from L to M to J, so I have to go through this way. So that's 25 plus the 180, that would be 205. And then KNM, so I start at K, I pass by N and go to M. So it should be this part, which is going to be 180 plus 68 is 243. Cool. All right, next part. Find the measure of the given arc. I want to find AB. So I know because these lines are 9, I know these arcs have to be the same. Has no relationship, it would be 9, just to the fact that they're equal to each other is what I could guarantee. Now I know every full circle is 360. So 360, I'm going to subtract 118 from that. That'd be 242. But since I have two x's, I'm going to divide by 2. And that's going to give me 121. And the reason I'm just being slow about this is because I'm tired. I apologize for not being so quick with the math. Next one. Because these lines are equal, I could tell these parts are equal. So if this is 52, this is also 52. Because this is a diameter, I could tell that this part is at a 180. So if this is 52, so 52 minus 180, that should be 128. So I know this is 128. And I could probably also conclude this is 128, but I didn't ask for that, so why even mention it? All right, hopefully you remember an angle that's inscribed, that's at the edge of the circle, is half of the arc. So if this is 154, it's 154 divided by 2. So this angle is 77. Over here, in a in a quadrilateral that's inscribed in a circle, the diagonal angles or opposite angles are supplementary, so they add up to 180. So the first one, 3x plus 114 should equal 180. And for the second one, it is going to be 4y plus 3 plus 105 equals 180. From there, you do a little bit of algebra. And I'm just going to do it to make sure you have an answer to compare it to. So this is going to be 22. And then over here, 180 minus 108 divided by 4, this is going to be 18. Next one. In this situation, when you have an angle on the outside of the circle, you subtract the arcs. So this big arc minus this small arc. Now, it would be 120 minus the small arc. But it looks like I didn't tell you the small arc. So how do we figure out the small arc? Well, we know all full circles are 360, which means if this is 184 and this is 120, this should be what's left over if I took it out of 360. So it is going to be 56. All three numbers together add up to 360. In this case, because I'm dealing with the angle on the outside, I do 120 minus 56, 6 divided by 2 equals x. So in this case, 120 minus 56 is 64, divided by 2 is 32. This is 64 divided by 2, that's 32. So that's the angle on the outside. When I'm talking about an angle on the inside, you average the two angles. If this is 129, I should know from minus 180, because it's a linear pair, this is going to be 51. So I know it's going to be 35 plus a mystery x divided by 2 equals 51. I would times 2 on both sides to make my life easier. So 35 plus x equals 102. Minus 35 on both sides, that would be 67. And makes sense. The average of 67 and 35 is 102. All right. This one, again, it's a circle on the outside, angle on the outside, so it's big minus small. But again, Mr. Tobel is pretty tricky. I gave you the big arc. Yeah, I didn't give you the small arc. So how do you find the small arc? Well, you should know all circles are 360. So if this is 230, this leftover stuff will be 130. So it's going to be 230 minus 130 divided by 2 equals x. 100 divided by 2 equals 50. So this is 50. Over here, find AB and BC. So I need to find this guy, I need to find this guy. Lucky for me, this is an angle at the edge of the circle. So if this is 20, this is 40. If this is 40 and this is that diameter, that means the circle is cut in half. So if this is 40, this should be 180 minus 40, or 140. This one, when you have chords of a circle, you take the two pieces of the chords and multiply them to the other two pieces of the chord. So 6 times x equals 3 times 4. Hopefully you can see that x ends up being 2 in this case. In this one, it is outside times the whole thing. So it's going to be 4 times what 4 plus 6 is, aka 10. And over here, it's going to be x times x plus 7. In this case, it's going to be some quadratic. So this is 40 equals x squared plus 7x. Subtract 40 on both sides. 0 equals x squared plus 7x minus 40. I need things that multiply to 40 that add to 7, negative 40, that add to 7. That is going to be, this was 10 together. 4 and 10, no. 8 and 5, yes, no. What is this? 2 and 10, 2 and 20. Something wrong with this question? 4, yeah, this question is not doable, at least with factoring. Oh, did I change the numbers, I think? Now I'm thinking, did I change the numbers? Maybe. This is not doable by factoring because nothing multiplies to negative 40 that adds to 7. 2 and 20, no. 4 and 10, no. 8 and 5, no. So yeah, nothing works. So I'll make sure the question works, but you do factoring. Remember though, when you do the factoring, you're going to get a negative answer and a positive answer, most likely. It does not make sense to have a negative answer. You don't have negative feet. You can't be negative 3 feet tall. So it's just always going to be the positive answer. Hopefully this one works. So in this case, this is outside times the whole thing. But because the outside is the whole thing, it's just 16 squared equals 14 times the whole thing, which is going to be 14 plus x plus 2. So 16 squared is 256. I should have known that. 256 equals 14 plus 16. 14 plus 2 is 16, so x plus 16. So it is going to be 14x plus 14 times 16 is 224. Subtract 256 from 254. And if I remember, this one is a decimal, 32. Yeah, it's a decimal. 32 divided by 14x divided by 14, it'll be 32 over 14, which we could simplify to 7 over 16, 16 over 7. So 16 over 7. Or whatever decimal that is, which would be like 2 point something. Same thing here. We're going to do a cross multiplication, but it's piece by piece. So this multiplies with this multiplies with this. So it's going to be 5 times 5, or 5 squared, equals 4x times x. So this is going to be 25 equals 4x squared divided by 4 divided by 4. 25 over 4 equals x squared. Square root both sides. The square root of 25 is 5. Over the square root of 4 is 2. So 5 over 2 should have been your answer. Over here, number 16, again, outside times whole, so 9 times the whole thing. So 9 times 9 plus 7, which is 16, equals outside times the whole thing, which is just the same thing, x squared. So 144 equals x squared. That should be 12. This one, I feel like I remember this one. I think this one also couldn't work or something like that. I think I made it into 28 if I remember. If I remember correctly. So let's just try it with 28. So x times x plus 28, because I need the whole thing, equals 8 times 8 plus 8, which remember is 16. So in this case, 8 times 16 is 128. And then this is x squared plus 28x. Got to set it equal to 0 because I'm factoring. And then I need things that multiply to 128 that negative 128 that add to 28. In this case, it's going to be x plus 32 and x minus 4 equals 0. Things that multiply to 128 that add to 28. Split and solve, you get negative 32 and positive 4. Negative 32 does not make sense as an answer because you can't be negative 32 feet tall, so 4 is your answer. Okay, now this next section is going to be based off the tests or the stuff we learned while I was away. Well, I taught you most of the stuff, but this is a version of my test. You'll have some of this formula, so don't sweat that. Let's first just talk about shapes in general. Remember, a pyramid hits at one point. Enable editing, please. A pyramid hits at... Okay, buddy, can you calm down? A pyramid hits at one point, and the bottom of the shape is called the base. So even though I don't think I asked a question to name them, in this case, this is a rectangular pyramid because the rectangle is on the bottom, but it's a pyramid because it hits all at one point. When you have a circle as a bottom, we have a special name for that. It's not a circular pyramid, it's called a cone. So that was a cone. In this case, this is a little hard to tell. This is a triangle, and on the other side is another triangle. So this is a prism. A prism has two sides of the shape being the same. I'm putting my hands up, but I realize you can't even see it. My bad on that. But either way, there's two triangles on both sides, so that becomes a triangular prism. So something like this. Again, I will not test you on naming, but let me just talk about it while I have it. Here, circle, circle, prism. You have a circle on top, you have a circle on bottom. That's a prism, but we call that a cylinder. So that's a cylinder. In this case, I have a triangle over here. I have a triangle over here. That is a prism because I have two sides of the shape on both sides. So that is a triangular prism. Again, I will not test you on this, so please don't ask me. This case, it's a ball. That's a sphere. That's a mathematical term. In this case, this is a triangle on one side, but it meets a point on the other side. So this is a triangular pyramid because it meets up in one point. It doesn't have a mirror edge like over here, where you have a side over here and a side over here. Now, this is considered a rectangular prism. You could argue, Mr. Tobel, if this is a square, is it a square prism? I would say, yeah, it is a square prism, but all squares are rectangles. So we are lazy and we just call it a rectangular prism. All right, let's find the volume for this. So the volume is going to be, this is a rectangular prism. So it's always volume is capital B base times height. So capital B base times height, in this case, it is length times width because it's a rectangle. So it's just going to be 7 times 13 times 9. So 7 times 13 times 9, it's so obvious. I'm thinking about it in my brain right now as I type it into my calculator, is 819. Surface area for a prism. This is a prism, remember, because it has a top and a bottom, okay? Let me go back to the formula. Let me see if it matches the formula I gave you. Surface area, surface area, surface area. Gives you LA. What the hell is LA? Oh, lateral area. All right. So in surface area, the formula I think I give you, and I want to be consistent. I'm going to pause a little bit to see what formula I gave you on the notes. All right, I will make sure that the formula matches what we learned. So what we learned was perimeter times height. This is the 2D height, plus 2 times base, okay? So first, we want to talk about the perimeter. So we're going to choose which one's the base. I'm going to put what is the bottom as the base. So the perimeter is all the pieces added up. So 7 plus 13 plus 7 plus 13 because it goes to the other side. So that's going to be 7 plus 7 plus 13 plus 13. I could have done that in my head. That's 40. That's the perimeter of the bottom part because this is also 7 and this is also 13. Times the 3D height. So the 3D height is the height going up from the bottom to the top. So this is going to be 9. Plus 2 times the capital B. The capital B is the area of the base. Remember, I could claim this one to be my base. So that is going to be 7 times 13, okay? So it's going to be 40 times 9, 360, incidental, plus 2 times 7 times 13, which is 182, plus 360, that would be 540, 542. So the answer for this one's 542. All right, next one. What is it? PH plus 2B. Good. All right, this one is a trapezoid one. I'm going to be straight up. I'm not going to be a trapezoid. I don't want to waste my time. Let's go to the next one. Circulars, cylinders, okay? Cylinders, for the volume of the cylinder is capital B times H. Capital B is the area of the base. In this case, the base is a circle, so that's pi r squared times H. Now, remember, r is not 13. That's the whole diameter, so I need half of 13. So 13 divided by 2 is 6.5. So pi times 6.5 squared times my height, which is my 3D height, which is 19. So it is going to be 6.5 squared, so 6.5 times 6.5 times 19. So I end up getting 802.75 pi. That's for my volume. 802.75 pi. If I give you it as decimal in the multiple choice, let's times it by 3.14. Surface area. The surface area, again, is PH plus 2B. So P is the perimeter. The perimeter of a circle is the circumference. So that's 2 pi r. Times the 3D height, which is going to be 19 in this case. And r is 6.5. I guess I could have plugged that in. Plus 2 times the area of my base, which we kind of found earlier, but just a reminder, it is 6.5 squared times pi. So 2 times pi, 2 times 6.5 times 19 is 247 pi, plus 2 times 6.5 times 6.5. Let me do 6.5 times 6.5 times 2 is 84.5 pi. And then you could add that together. 331.5 pi. Okay. Next one. This is a pyramid. The pyramid has different surface area and volumes. First volume is just 1/3 capital B base times height. Okay. So in this case, it's 1/3 base times height. So it's 1/3 times my base, which is length times width in this case, because it's a rectangle or square, I guess. So 16 times 16 times my height, which in this case is 6. So 1/3 times 16 times 16 is going to be 512. So this is 512. Now the surface area for a pyramid, and I'm just going to look it up just to make sure I give you the same surface area as I did last time, is, I'm going to write it this way, 1/2 the perimeter times the L, which is the slant length. We'll talk about that in a second. Plus B, which is just the area of the base. It's not 2B because we only have one base here. So it's just single base. All right. So 1/2 times the perimeter, which is 16 plus 16 plus 16 plus 16 is 16 times 4 is 64. Times the L. So the L is like the diagonal length that goes along the pyramid. This would be the stairs of the pyramid if it was a real pyramid. So if I were to draw as a right triangle over here, I would know the height is 6, and this would be 8 because this would be half of it. If this is 16, then this would be 8. So 6, 8, the hypotenuse, hopefully you can see that's a 10 because it's a 3, 4, 5 triangle. So in this case, my L is 10. Plus the area of my base, which is 16 times 16, or 16 squared. So 32 times 10 is 320 plus 256. And that's going to be 576. So 576. Okay, a cone. The cone of volume it's a pyramid, so 1/3 base times height. So 1/3 times the base, which is pi r squared, times height. So 1/3 times pi. My r is not 5, it's 2.5 in this case, squared, times my height, which is 8. So 8 times 2.5 times 2.5 times, or divided by 3, that'd be 16 and 6 repeating. So 16.6 repeating pi. So 16.6 repeating pi. Okay. The surface area is, again, I just want to make sure I don't mess it up, is 1/2 PL plus B, 1/2 PL plus B. So in this case, my 1/2 times my perimeter, which is 2 pi r, which is 2.5 is r, times my slant length. I got to figure out what my slant length is. If this is 2.5 and this is 8, I have a right triangle that kind of looks like this right now, where this is 2.5, this is 8. I need to find the answer to that. So 2.5 squared plus 8 squared, and then square root that. It's going to be about 8.4. So this is going to be this is 8.4, about-ish. So this is 8.4-ish. The lateral height, remember, that's the side of this part. Plus my capital B in this case, which is going to be the area of the base, which is, again, pi r squared, or pi times 2.5 squared. In this case, it's kind of interesting where volume's a little easier to always do compared to surface area, but it is what it is. So this is 8.4 times 2.5. So that's 21 pi over here. Plus 2.5 squared should be 6.25. 6.25 pi. So add that together. That's going to be 27.25 pi. Okay. All right, next one, number 6. This is volume. For the sphere, it has its own formula. For its volume, is 4/3 pi r to the third power. And for surface area, it is just 4 pi squared, r squared. So not as bad. This is the one where I think volume is a little bit more annoying than surface area. So this is 4/3 times pi times r, which is 7 cubed. So 7 cubed, or 7 times 7 times 7, divided by 3 times 4, should be 457.3 repeating pi. And then this one, surface area, is 4 times pi times 7 squared. So not as bad. 4 times 7 times 7 is 196 pi. All right, and then did we do anything else? Oh, shoot, I didn't even do the area. I did volume first, I think. Well, okay, well, that's awkward, but all right, let's do area. Area stuff, we could do that. So again, area, you're gonna get some formula sheet. I think I gave it to you already, so you can look at that. I'm just gonna change, make sure the surface area matches what we had before. So this one over here, this is the parallelogram. When a parallelogram, it is base times height. So if this is my base, because it's touching, air quotes, the right angle, and this one will be my height, 16.1, because that's based off the right angle. When you take your own height, you stand up straight, you don't stand up slanted. So 11.8 times 16.1, that's 189.98. So 189.98. Would I allow you to round out up to 190? I wouldn't mind. All right, this one. This is a semicircle, so that's half a circle. So you know the circle is pi r squared. Hopefully you know the area of a circle is pi r squared. But in this case, because it's half a circle, I divide it by 2. So pi times 17 squared divided by 2. So 17 times 17 divided by 2 is 144.5 pi. 144.5 pi. This one is a two-piecer where you have this triangle over here and this semicircle. So this is half a circle. So we could do this part first. We'll call this part 1. And then we're going to do the triangle, which is part 2. So part 1 is 16. So it's going to be a circle, which is pi r squared. So pi r squared. But it's divided by 2 because it's half a circle. So it's pi times 16 squared over 2. So it's going to be 16 times 16 divided by 2 is 128 pi. So this is 128 pi. Over here, I need the triangle. So if this is 8, this is 17, I need to figure out what the height of this guy is to figure out the height of my triangle. I do the Pythagorean theorem, I'll end up getting 15. This is a Pythagorean triple, 8, 15, 17. So I could do the base times the height divided by 2. This one's for a triangle, it's base times height divided by 2. Base times height divided by 2. So it's going to be 16 times 15 divided by 2. It's going to be 8 times 15, which is going to be 30 times 4, which is 120. In this case, I'm going to change this into a decimal because I need to be able to add this to 120. They're not all times pi in this case. So I'm going to change that to 402. I'm just going to round it to, honestly. So 402 plus 120 is 522-ish. Again, I am rounding. All right, this one we definitely had is find the arc length, this piece, of JH, and then the shaded region. So remember, this is part over whole equals part over whole. So 72 degrees is part of the circle I'm talking about, while the whole circle is always 360 degrees. Now I want to find the arc length of JH, so I'm going to put that X. But if I'm talking about the arc length, that's the edge of the circle, I'm using circumference, which is 2 pi r. Now I know what r is in this case. It tells me over here, which is 17.2. So it's 2 times pi times 17.2. So 2 times 17.2 is 34.4. Times that by 72, divided by 360. This is going to be 6.88 pi. I'm going to leave you to do the cross multiplication yourself. Over here, the sector area, the setup is almost exactly the same. You're still talking about 72 degrees. You're still talking about 360 in the circle. You're still talking about the mystery, but in this case, we're talking about the area of the pizza slice, so like the cheese on the pizza slice, divided by the sector area, which is going to be pi r squared, okay? So pi r squared, where r is going to be, again, 17.2. So again, I'm just going to do it in my calculator. You can handle the cross multiplication. Times 72 divided by 360. I end up getting 59.17 pi. I'm being arbitrary with where I round. I'm not going to go crazy about it. Okay, in this one, I want to find the line which is QS. That's my radius. So this one's a little different. Because I'm looking for the radius, when I know the shaded area is 17.26 and I know my angle's 100, what I can do is figure it out by doing part over whole again. I know it's 100 degrees out of 360 degrees equals, in this case, I know what my piece is, 17.46, divided by, in this case, I want to figure out what is the circle or the radius. So I'm going to use the formula pi r squared. So in this case, I'm going to have to find r by itself. I'm going to do a little bit of algebra, and I'm going to get r squared equals 360 times 17.46 divided by pi times 100 on the bottom. And then I'm going to have to square root that. So I'm going to just do it in my calculator. 17.46 divided by 3.14 divided by 100. Square root that. It's about the square root of 20. Oh, wait. Square root of 20. I get about 4.47. Your rounding might be way off compared to mine's. If you're in like 4.4 to 4.6 range, you'll be fine. All right, this one. I know this part is 15 inches. This is 60. I just want a circumference. Find the circumference. So I need to figure out what r is first. So I got to do the same concept. 60 over 360 part over whole equals, in this case, I know the top part is 15. 2 pi r is my circumference. A little bit of algebra. I have to clean this up. Give me a second. So I'm going to do 2 times 3.14 times 60 divided by 360 divided by 15. No, I did something wrong. Let me clean it up first. So r should end up equaling, if I multiply r here and I move everything over, 15 times 360 divided by 2 pi times 60. So 15 times 360 divided by 2 divided by 3.14 divided by 60. I end up getting 14.3. Oh, 14.3 is my radius. So r equals 14.3. So take this radius and then put it into the circumference, which is 2 times pi times 14.3. So times 3.14 times 2 equals 90. So I end up getting about 90. All right, next one. If the circumference of the circle is this, what's the area? So if I know the circumference is 2 pi r, and I know it's 62.8 equals 2 times pi times r, I could divide both sides by 2 pi. So 62.8 divided by 2 divided by 3.14 equals 10, actually. I guess I made it on purpose, so it's a clean number. Well, I'm sorry, 10 is r. So r equals 10. Then I'm going to take r and plug it into my area. So my area is pi r squared, or 10 squared times pi, or 100 times pi, or 314 if I do 3.14. All right, find the area of the following polygons. Okay, so this one, if you remember, it's the area equals 1/2 the apothem times the sides, the size of the sides times the number of sides. You might see it as AP2, as apothem times perimeter. Now the apothem is the line that goes from the center to the middle of the side here. So in this case, I already know it's 16. That's cool. So 1/2 times 16. Now I need to know how long each side is. Lucky for me, I do know how long this side is. This is 13.3. And now I need to know what n is. This is how many sides it is. Lucky for me, I passed kindergarten, so I could count 1, 2, 3, 4, 5, 6, 7, 8, that this is 8 sides. So with all that in mind, I could actually just calculate this. This one is pretty straightforward. So 1/2 times 16 times 13.3 times 8 equals 851.2. 851.2. Really easy on that one. But I tricked you guys. It's not going to always be that easy. So this one is number 10. So I tell you how long, again, I need 1/2 A, S, N. I need all three things, okay? So 1/2 times my apothem, which I give you is 10, But now I need the size of the side. At least I know it's a five-sided shape. That makes my life a little easier. So what I need to do is make a right triangle out of this. Now, if I made a right triangle out of this, I got to figure out what this angle is, or I need to figure out what this angle is, because I know this is a right angle. Because this is a five-sided shape, I should know that all the angles should add up to something. The five-sided shape should add up to what? You use 180 times n minus 2. Hopefully you kind of remember this thing, where n is the number of sides you have. So 180 times 5 minus 2, that's 3 times 180, that's 540. If this is 540, then that means I can figure out what each angle is over here. Each angle is going to be equal. So it's 540 divided by 5. So that's going to be 108. Well, if each angle is 108, I can figure out what this guy is. 108 divided by 2 is going to be 54. So this little guy is 54. Now the question is, you should ask, so what? I figured out that's 54, Mr. Tobel. What can I use that for? Well, lucky for me, if I know this is a right angle where this is 10 inches and this is 54 degrees, what I can do is now take this and figure out what this bottom piece is. Because if I could figure out what that bottom piece is, I could figure out what this whole piece is. If I could figure out that whole piece is, I would figure out what S is. So looking at this, it's a trig question. Look at that, how that happens. So in this case, I have an opposite and I have an adjacent. So I have TOA, tangent. So tan of 54 equals opposite 10 over adjacent x. So it's going to be 10 divided by tan of 54. And I got to make sure I'm in degrees. Yes, I'm in degrees. So then this is going to end up being 7.27. So I figure out this is 7.27. Well, does that help me? Yeah, because this is also 7.27. 7.27 times 2 is going to be 14.54. So this is 14.54. Because that's 14.54, now I could do my math, which is half times 10 times 14.54 times 5, which ends up being 363.5. How much more I have of these? I'm going to skip that and just go to here. Find the area of the shaded region. This one is going to be number 12 over here. I know the square is 25. If I know that square is 25, I know this is 25, which means I know the radius is 12.5. So I know the big square is 25 times 25, which is going to be obviously 25 times 25, 625. But the circle, that's the hole that's getting cut out here, is going to be the area of the circle. So that's going to be pi r squared, which is pi times 12.5 squared. Since I'm interacting with another number, I'm going to have to actually calculate with pi. So it's going to be 12.5 times 12.5 times pi. So 3.14. I get 490.625. I'm just going to put 6. And then I'm going to take that and subtract it from each other. So 625 minus 490.6. That's going to be 134.4. Remember, you take the big shaded area and subtract it from the circle you're cutting out. Here, to find the area of the shaded region, we want the area of the big area, which is 14 times 25. The area of the big space, 14 times 25, is 350. Great. Now we want the area of the small area. If I know that side is 25, I know this side is 25. And the area of a triangle is 1/2 base times height. I don't know how I got that mixed up. 1/2 base times height. There you go. So then it's going to be 1/2 times my base, which is based off the right angle, which is 25, times my height, which in this case is 11, because that's what it told me right here. So 11 times 25 times 0.5, that's going to be 137.5. 137.5 Subtract that from 350. That's going to be 212.5. Oh, that's it. I hope this helps. I'm tired. I'm done. Good luck with your final.